For the first time, scientists have photographed the sun's elusive Antarctic, indicating that the sun's magnetic field is ready to explode like a barrel of gunpowder. We see the sun every day, but it is a rare and worthwhile event to get a really fresh look at the star. So thank you. For the first time in history, scientists have been able to capture one of the poles far from the sun. Unprecedented images of the sun pole have been obtained thanks to a spacecraft called the Solar Orbiter. The probe, led by the European Space Agency (ESA) and NASA's cooperation, was launched in February and has been monitoring the sun since November. But the fascinating and unique part of the newly begun mission, study the poles of the sun. From the Earth and even to other spacecraft, our view of the sun has always been limited. We have always had a good view of the central part of the sun, says solar physicist and senior scientist at Solar Orbiter Project, Daniel Muller. But the poles are virtually visible, because we almost always see them from the edge. Earlier this year, our vision improved when Solar Orbiter passed by Venus in a precise and harmonious movement. The maneuver removed the spacecraft's path from the outlet, the plane on which the orbits of the planets and the equator of the sun coincide. The new images show the sun's Antarctic and were taken in March. According to Muller, the spacecraft also crossed the Arctic in late April, but is still sending that data to Earth. It is harder to take pictures of the poles of the sun than it seems, because to do this, a spacecraft has to get out of the circle. Exit this orbital screen for spacecraft, a costly and fuel-efficient maneuver. But this is exactly where Solar Orbiter shines. By the end of the mission, the orbit of the spacecraft will be tilted at a 2-degree angle to the ecliptic, and it is the tilting circuit that allows unprecedented observation of the sun's poles. The new vision is valuable to scientists, because the poles of the sun are not just geographical poles, they are also some kind of magnetic poles of the sun. The sun is a huge vortex of plasma that produces and then disappears, a process that drives the 6-year cycle of solar activity. In minimum solar, the lowest level of activity of the solar activity cycle, the sun's magnetic field has a state of what scientists call dipole, like a large rod magnet with strong poles at its two ends. But with the sun's rotation, roaring plasma creates sunspots, dark and relatively cool areas on the surface of the sun resulting from the entanglement of magnetic field lines. With the emergence and disappearance of solar spots, part of the magnetic energy is released and migrates to the nearest pole and changes the polarity of the existing magnetic field. The result is a transient and strange situation. The poles of the sun enter a complex phase in which parts of the north and south polarization are scattered and irregularly intertwined. Solar activity affects our daily lives. Eruptions such as flares and mass outflow from the solar corona can pass through the solar system and reach the Earth. These eruptions are driven by the constantly changing magnetic field, and when they reach the ground, they can disrupt power grids and radio systems. In orbit, they endanger satellite communications and navigation systems and even threaten astronauts. Therefore, scientists are trying to predict the space climate as they predict the Earth's climate. But to achieve this goal, they need to have a more accurate understanding of how the sun works, and it is almost impossible without a proper view of the magnetic activity at the poles of the sun. The poles of the sun, as they seem, are not unknown and mysterious. Although Solar Orbiter is the first spacecraft to send real images of the poles of the sun, it is not the first spacecraft to cross these areas. This title belongs to the Ulysses mission, a joint project between NASA and the European Space Agency that was launched in year 2 and was active until year 2. Ulysses had a set of scientific tools for studying energetic particles, magnetic fields, and other solar phenomena. The spacecraft achieved important findings about the sun and its amazing poles. But it had a major drawback: it had no camera. For this reason, despite all the insights he provided, he left no image of those areas.